Welcome to EEG World. This is episode 2, entitled Why ERPs? I'm Nikki Wittridge, and today I'm joined by Dr. Yuri Kropotov and Rustam Yumash. Rustam is the director of the Brain, Mind, and Memory Institute in Sydney, Australia, and a clinical neurofeedback practitioner. And Dr. Yuri Kropotov is a preeminent neuroscientist, a co-creator of the HBI methodology and database, the author of 3 books, and dozens of scientific articles. Today we discuss the value of event-related potentials in clinical practice, information flow theory in the brain, and other topics. You can check out those topics in the description below or in the chapters of this episode. And if you'd like to support the show, you can do so at patreon.com/EEGworld. Thanks for watching, and now I bring you Yuri Kropotov and Rustam Yumash.
So thank you, Yuri, for giving your time. So I would like to propose the first question to eliminate your understanding of how the brain operates as a bunch of different networks and give us some idea about how we can get some insight about these networks, the modern understanding of brain function from the point of view of event-related potentials.
Well, it's not an easy question, and I think that nowadays everyone understands that there are different systems in the brain that perform different functions. And when you look at what's happening in the brain, you can see how different systems interact with each other. And this interaction, the functioning of this system, are reflected in EEG, in event-related potentials, of course, in functional MRI, and in other parameters that can be measured from the brain. But of course, today we are talking about event-related potentials. And if we talk about event-related potential, then we talk about stages of information flow in the brain. So basically, we could say that event-related potentials recorded from the skull can be decomposed into separate component, latent component, and each of these components has a special topography, which actually define the special distribution of the neuronal networks and functional dynamics, how this component responds to different tasks, to different functions. And I think that this differs the method of event-related potentials from any other methods. And of course, the component that can be obtained using this methodology could be different from the component that could be obtained, for example, for the spontaneous EEG could be different from the component that can be separated from the functional MRI studies. And because we are looking at the brain through different windows, and each window provides a special view to the brain with special parameters with special which have special meanings. And I think that maybe during this conversation I try to emphasize and clarify what I try to say when I talk about the functional meaning of the neural networks and of the component that can be separated from event-related potentials. As I said, the ERP provides a new window to the brain functioning. And the ERPs reflect stages of information processes in different brain systems, like sensory systems, visual, auditory, executive system, affective system, memory systems, etc. And this is quite different from resting state EEG. In spontaneous EEG, in the resting state, we see several EEG rhythms, such as occipital parietal alpha rhythms, mu rhythm, frontal beta rhythm, Rolandic, central beta rhythm, frontal midline theta rhythm, and some other rhythmicities. So this rhythm we know from neuroscience are neuromarkers of different mechanism of cortical self-regulation. And this mechanism of cortical self-regulation are implemented by different types of cortical, subcortical neuronal networks. And here, on the right, I demonstrate an example of neuronal networks that generate alpha rhythms. So, and this rhythm, this network consists of neurons in the cortex, pyramidal cells and stellate cells, inhibitory cells, and the thalamus, the neurons of the thalamus, thalamocortical neurons, and inhibitory neurons in the reticular nucleus of the thalamus. I just remind you that reticular nucleus of the thalamus, this is a kind of a layer of inhibitory neurons that surround the thalamus and that send feedback inhibitory connections to the thalamocortical neurons. And these networks, we know again from neuroscience, generate rhythmicities, and the frequency of these rhythmicities depend on the activation of the cortical neurons. So if this activation is high and the depolarization of the thalamocortical neurons is at the high level, these networks generate alpha rhythm. If this depolarization, the cortical activation is low and depolarization of these thalamocortical neurons is low, then these networks generate rhythmicity in the theta frequency band. Okay, so I'm just, this is example. This is a good example of a mechanism, neuronal mechanism for generated a family of alpha rhythms. So the frontal midline theta is generated by a different neuronal networks, which includes hippocampus as a node, as an important element in this network, etc., etc., etc. So I'm not going to go into detail. Okay, here I just have to mention Hans Berger. He was the founder of this method, and he was the first who recorded alpha rhythm. And at the bottom, this is the figure from his paper that he wrote in 1924. And here I present typical and atypical alpha rhythms, again, as an example. And this is the results of studies in healthy subjects and several group of patients with different psychological, psychiatric conditions. And here I present by green the areas where typical alpha rhythm are generated. They are occipital, parietal, and the so-called mu rhythms. And there are typical locations of alpha rhythms that can be seen, for example, in children with autistic spectrum disorder. The alpha rhythms and T5, T6 electrodes. And also at the prefrontal areas, for example, at area F7, asymmetrically, these rhythmicities can be found in some patients with the depression. So these studies and research and also analysis of continuous EEG is provide the way how we can compare the EEG in a certain patients with the database, and how we can construct a protocol of conventional neurofeedback. When I say conventional, I mean the EEG in the frequency band from 0.5 to 30 hertz. And we know that there are several waves of neurofeedback, like you can train theta, alpha, and beta rhythmicities or ratios or coherence within these rhythmicities. And on the right, I can show you an example of a subject who can actually, by will, he is able to generate a relative beta rhythm at the frontal areas. Okay, so in contrast, event-related potentials reflect brain responses in the task. So you ask the subject to perform some task. There are different types of tasks. So, for example, the task that use auditory stimulus or visual stimulus or some of the sensory stimulus. There are audible tasks, there are go, no-go tasks. There are different types of tasks which ask the subject to perform different functions. And that is why we can separate from this task, from ERPs that recorded during this task, different functional components. Okay, so basically you ask the subject to perform the task. Task consists of many trials. In each trial, the subject receives a stimulus and he has to perform some task with the stimulus. For example, a response to go stimuli and do not withhold from pressing a button in response to no-go trials. And that is why the ERP obtained by averaging EEG over many trials, and to get a good signal-to-noise ratio, you need to average quite many trials. Of course, how many depends on the functional task that you perform, the subject perform. Okay, and here I need to mention a famous English neurologist, Gray Walter, who was the first who recovered a wave, a component of event-related potentials, which is called contingent negative variation. And by the way, I met Gray Walter And he was very good of our laboratory. He visited, in those days, Soviet Union several times. Okay, why we are using ERPs in our clinical practice? First of all, the diagnostic power of event-related potentials is superior in comparison to that of EEG spectra. And well, if you look at the literature, at the scientific literature, then you can find the number of papers, research, scientific papers about event-related potentials and, say, diagnosis in clinical practice are much higher. These numbers much higher than that in of papers which study EEG spectra and use them for diagnosis in clinical practice. So the next thing is that the effect sizes of discriminations of ERPs in some psychiatric conditions from healthy subjects exceeds the value of 0.8. Remember, the effect size is the difference between different of the parameter between healthy subject and patients divided by standard deviation. Okay, and when the effect size is higher than 0.8, that means that you can use them in clinical practice, so on individual level. And quite often when at the individual level, no deviations in EEG spectra from the reference are found, ERP give you the only clue for diagnosis of brain dysfunction and for constructing a protocol of neuromodulation. And here I presented just an example to give you a kind of a flavor what I'm talking about. So on the left, this is EEG spectra, the two components of EEG spectra in schizophrenic patient and in healthy subject. And you can see there are differences, statistically significant differences, but as you can see even by naked eye, you can see that the effect size is not big. The relative changes are not big. And on the right, ERPs again in healthy subjects and in patients with schizophrenia. And even by naked eye, you can see that the difference is quite high. And the effect size, believe me, is higher in event-related potentials. Then ERP deviation from the reference offer protocols not only for neurofeedback, but for other neuromodulation techniques such as TMS, transcranial magnetic stimulation, TDCS, transcranial direct current stimulation, and photobiomodulation technology recently developed. Okay, and here I present these ideas. So not only conventional neurofeedback protocols can be used, but also protocol for ELF, especially for discrete type of ELF and neurofeedback. And the ERP can be used for constructing protocols of transcranial direct current TMS and photoneurobiomodulation. The methodology that I just mentioned above has been described in more than 100 papers published in quite high-ranked journals, and 7 books, including books by Elsevier and Springer. The HBI database is commercially available, and this database provides a modern approach to ERP analysis, which includes different methods, included methods of blind source separation. These are the books that I just mentioned, published. The first book, Quantitative EEG, Related Potentials in Neurotherapy, described the methodology itself. The second book, published in Springer in German, is described application of methodology for clinical practice in ADHD, in attention deficit disorder. And the third papers that actually describe how ERP can be applied for other psychiatric conditions like schizophrenia, OCD, depression, etc. Okay, so here I show the equipment that can be used for implementing the methodology, which includes equipment, amplifiers, MITSAR 201 or NeuroAmp biomedic device for 19-channel EEG recordings, software for EEG assessment and ERP assessment. It could be either WinEEG of HBI database, and you can find them on this website that I presented below. And basically, that's all I wanted to share with you.
Thank you, Yuri. That's amazing. I'm sure we really would love to hear more about your method and discuss different case studies in the future. This is what we're planning with Nikki, to investigate and eliminate different aspects of application. As I mentioned previously, some colleagues wanted to know how to interpret different components of ERPs, especially those that significant deviation for their clients. So I guess there's more technical aspects that they need to learn at your workshops and webinars, which we probably can offer in the future. Yeah,
that's true.
Do you want to mention how neurologists and clinicians using these components?
Each of the components has a special functional meaning. And if you look at different disorders, psychiatric conditions, then you can see that each of these diseases has a special profile of ERP deviations from the normality. So any dysfunction is characterized by a specific pattern of abnormalities. Okay. And for example, the patients with autistic spectrum disorder, fine functioning autistic spectrum disorder, they have all executive components normal. And the only abnormality you can see in so-called visual preparatory activity. So when the subject is preparing for the second visual stimuli in the two stimulus go, no go task, which we applied in this study, and the patient in autistic spectrum disorder, they show deficit in this. So basically, the prediction and prediction error is impaired in patients with autistic spectrum disorder. So they basically see the visual world differently from us. And the same can be said for patients for schizophrenic disease. So they have a specific component which is impaired in this particular disease, etc., etc. So I can tell hours and hours, maybe days and days about this, and this is presented in the heavy books.
I can testify to that.
Thank you, Nikki. So, but briefly, when you look at the event-related potentials in particular subject, compare them, this ERP with a database, that you can see what part of the brain, what kind of neuronal network, functional neuronal network is impaired. And because we have several methods of neuronal modulation, we can suggest this method of neuromodulation for either activation of this area, is it what initially hyperactive, or just opposite, inhibiting this area if it was hyperactive before. So this is how it works.
To go back to the example of, ASD, when you think about that in terms of, qEEG findings, it can sometimes be difficult to see. Occasionally you'll find some abnormality in terms of like the posterior temporal regions where there may be some excessive alpha content or even possibly some excessive gamma content, although that can be more difficult to tease out. And so, I still definitely consider myself a beginner in this methodology, but one thing that sticks out in my mind as an example of where the ERP can be so valuable is in that, what you just mentioned, the preparatory response, the sort of anticipation, the visual prediction. That's something that you get a window into with the ERPs that you just don't have in the steady state qEEG. And not only that, but there's a sort of higher, whatever you want to call it, statistical reliability associated therein. So it's really fascinating to me, all the things that you can kind of learn from it, and I think to take a step back, there's kind of this, crisis of reliability in science, especially in related to psychology and psychiatry. And in the world of, neurofeedback, there's sort of this growing interest, there different players in the field are starting to bring forth, different ERP technologies. And it's fascinating to see, what you have developed as being this very, mature system, not just in terms of like how long you've been building the database and how long you've been creating the integration with the software and the reports, et cetera, but also the level of discernment and specificity that you've developed in finding specific biomarkers in different conditions. And I think that can't be understated. In the world of qEEG, it's constantly an issue of having different people look at the EEG to try to find out what's going on in there, which obviously can be valuable. I mean, I love having a smart person look at my EEGs as much as the next person does. But yeah, the ability to have a finding and for it to be really durable in the sense that two different scientists, maybe even from different subspecialties in the field, will come to the same conclusion in terms of what it means, because there's just not as much room for for error and sort of different interpretations when you're talking about specific ERP components.
Yeah.
Thanks, Nick. That's amazing.
Thank you.
Yeah.
Yeah.
I won't specifically mention the little bit down to earth, bring from the from your academic level to down to earth. This is a huge need for identifying the early identification of trauma, effect of the adverse life events on people, and what we see is a large number of percentage of our clients actually
You're talking
have
about
psychological
post-traumatic
post-traumatic stress disorder or complex PTSD or developmental trauma. They call it now developmental trauma disorder, DTD. What I've seen in so many of our clients that your reports were showing this early response of the sensory system to the signal, which always shows us that there is some kind of sensitivity exists in this client. And I've seen it so many times that then I start to dig symptoms and ask parents what happened to that person, to the child, for example, and they will bring up different events. It could be even brain injury itself could be affecting some of the networks, but then underneath you always find that one of the most disabling element is the trauma response, which prevents people from actually actively engaging in rehabilitation. That's what the most important thing I've learned from working with you. And so the last sorry.
Yeah, I'm just saying thank you, Rustam, for his support. Yeah.
And on that point, I think it's interesting too, because I think it again gives us, there's this level of like the advanced science and the complex analysis, but there's something very intuitive about that, which is that people who have experienced trauma have kind of a jumpiness to their response to sensory stimuli. And that's something that's not necessarily as visible in the resting EEG. But when you see it in the ERPs, it gives you the sense of like, wow, when this person has a simple visual event, often in trauma, you see sort of those first early components that go in this ultra fast pathway in the brain. They're really amplified, which then really shifts the way that they experience the world. And I think it, is associated with the feeling of like overstimulation, hyperexcitability. So I think there's something about that which I think intuitively helps us connect with like that person's lived experience.
Yeah, absolutely. And it puts arousal in the context. We in the resting state, we could not see the dynamics of arousal. That's most important aspect for neurofeedback, because we're working with arousal a lot. So one more question, Yuri. That's amazing. Thanks, Nikki, and thanks, Yuri. One more question came from the president of Applied Neuroscience Society of Australasia, Juri. What is the error rate of or reliability of HBI database? And you mentioned specific studies on test reliability. I think that's the most interesting question.
Yeah, it's definitely an interesting question about the test reliability. And of course, this was the first question that we have to solve, to answer. And we recorded a relatively large group of healthy subjects, and who came to our laboratory twice with several months between these recordings. And the recording was done by different amplifiers. We used different machines, and we used different rooms. The subject came to different buildings, so everything was different, except that the brain of the subject was was the same. And we recorded ERP, the first recording and the second recording. And we found that the retest variability was perfect, almost perfect, more than 0.9, 90%. I myself was recorded 7 times. Can you imagine? I was recording 7 times. Every time that we kind of made a new development in the system or in the software or the hardware, I use my brain to record as an example. And when I compared all these 7 recordings, I was amazed that they were almost identical. Can you imagine? I know the task. I know this task. I develop it. I know the stimulus, everything. I know. And every time that I did it, it was like a new task for me. And the reaction time was the same. The component, the amplitude was the same. The latency was the same. So basically, it's indeed, if you do it properly, it's a good method for recording what is happening in the brain, and the test reliability is very high. Of course, it depends on the task you develop and on how many trials you apply. So in our database, in this task that I'm talking about, we actually applied 400 trials. 400 trials is quite long, and it takes about 20 minutes to the subject from the task. But in these task conditions, the test reliability is very high.
That raises another question of we discussed it before about the how we can impact event-related potentials components with therapy. For example, I remember that after the 10 days meditation retreat, you found that my ERPs significantly changed, specifically cognitive control improved and CNV. So
yeah, I remember.
Yeah, so it's interesting. What would you say that we can impact ERPs in information processing? Do you see the significant changes from therapy?
Well, definitely using this method, it's quite easy to record before and after treatment. And especially if you have the comparison group, control group that gives you the idea what is happening in the brain during your treatment technique. Yeah, it's a good method, and we found in several cases that indeed, like neurofeedback changes ERPs quite reliably. And we actually published one paper about the effect of neurofeedback in ADHD patient, one paper, the effect of neurofeedback on patients with post-traumatic stress disorder, by the way. So we published several papers on this. Yeah.
So you could say that it's quite a precise method of pre and post comparison to demonstrate.
That's true, but in every case you need a control group. Without a control group, no one would believe you that this is because this happens not because of the time, but because of the treatment.
I would say that your method is amazing because you have normative database with different averages. That means that the many other people now trying to jump on on the train and use their own ERP method, but so far none of them have normative database, and so in this regard, your method is quite unique and still quite advanced compared to others.
Yeah. Well, although I have to tell you that there are many attempts to actually to develop the database, and as you know, there is a consortium which is called, I think it's called ERP consortium, and they use the evaluated potentials for pharmacological studies, for studies in pharmacology.
Well, that's a huge application indeed. Yeah. Well, that was an amazing interview. Thank you so much. You're really looking forward to have more meetings and cracking cases and discussing different aspects. Nikki, do you have anything to say?
No, I think, it's such a wide topic. And I think for the person who is already engaged in neurofeedback and neuroscience and neuromodulation, that entering into the world of ERPs, it's like kind of starting again from square one in some sense. I guess if people are watching this online, you can put questions that you have in the comment section, and then I'd like to hear from you, Yuri, like what your plans are in terms of when you're next going to be teaching and what this workshop is about.
Well, I'm teaching a group of clinicians from the United States. It's a wonderful group, actually. All people are dedicated, and all of them, they were recorded event-related potential, actually including you.
Yes.
Remember that we analyzed your cases? Your
yes.
Case? So it was very, very interesting to see. And it's very interesting to see that people, they actually open-minded. They want to add to their clinical practice something new that would improve, enhance their ability to diagnose and to treat patients. And of course, I think event-related potentials provide you a new option, a new tool, a new window to the brain that you can apply to your clinical practice. And this is a good thing. And then I'm going to Australia. Then I'm going to have, first of all, to have a master class, which describes event-related potentials. Then I have a workshop, a one-day workshop, again in Australia. And I'm going to resume working with your group from the group from the United States. And I think that I'm going to start it in November. In November, I know that I cannot come to the United States this workshop that Tiff Thompson is organizing. Remember this?
The School of Neurotherapy conference. I think it's November 2nd to 4th. So you'll be presenting virtually at that?
Yeah, I will prepare. I will prepare. So I cannot be on for many reasons. But I will prepare. I will prepare my presentation. I will send to Tiff.
Well, certainly a lot of interesting events, exciting events waiting us, and we will be learning more from Yuri. And please stay in touch with us, and we'll let you know when next events. You can register at braininstitute.com.au for the to be notified and about next events. And we have brain signals, ERPs and qEEG mentoring group as well. We're meeting fortnightly, and hopefully we'll start ERPs mentoring groups soon with Yuri as well. So thank you so much, Yuri. Thank you, Nikki. We'll till the next time. Exciting. Thank you.
Yeah. Now it's a question to Nikki. What
Yes.
about your postcard?